Hi everyone, today we will find how to solve the average RMS peak factor form factor of full wave rectifier sine wave. As we know, the full wave rectified sine wave consists of pulses during both the positive and negative half cycle. Okay, so the complete cycle is now can be taken as the pi interval. From the 0 to pi, all the sine waves are getting repeated. So here the voltage magnitude is mentioned as E is equal to, from the interval 0 to pi interval, E is written as Em sin theta. Now we are going to deal with the average value. So E average is calculated as the time period. For the time period pi, it becomes integral 0 to pi e d theta, where E is mentioned as, or E is rewritten as Em sin theta d theta. Em is a constant. Integral 0 to pi sin theta d theta, where integral sin theta becomes minus cos theta. Now apply the limit 0 to pi and it becomes Em divided by pi minus of cos pi plus minus of minus 0, that is plus cos 0, and we can solve it as Em by pi minus cos pi. Minus cos pi becomes minus 1, so minus of minus 1 plus cos 0 is 1. So we can calculate Em by pi into 2, that is 2 Em by pi, or it is equal to 0.637 Em. Now we have to calculate the RMS value. So E RMS is equal to square root of mean of a time period pi, and the integral varies from 0 to pi E square d theta, where E square is Em square sin square theta d theta, where Em square is taken outside, Em square divided by pi, integral 0 to pi sin square theta d theta, where sin square is rewritten as 1 minus cos 2 theta by 2. So it becomes integral 1 d theta, integral 1 is theta, and minus cos 2 theta, integral is minus sin 2 theta divided by 2, with a constant Em square divided by 2 pi is taken outside. And now apply the limit 0 to pi interval. So we can obtain Em square divided by 2 pi. Applying the limit theta, applying the limits to theta, it becomes pi minus 0, that is pi. Now apply the limits on the second term, that is minus of sin 2 pi divided by 2, minus of minus sin 0 by pi. So sin both the terms becomes, for both the sine terms it becomes 0, and E RMS is calculated as square root of Em square divided by 2 pi into pi. So pi and pi get cancelled, it becomes Em square divided by 2, which is equal to Em by root 2. That is E RMS value is 0.707 Em. Now for finding, it is easy to find the peak factor and form factor. For the peak factor, we know that Em divided by E RMS. Em by E RMS is substituted as 0.707 Em. So the peak factor is calculated as 1.414. And for the form factor, it is E RMS by E average. E RMS is substituted as 0.707 Em, and E average is also calculated as 0.637 Em. So Em and Em get cancelled and the form factor will be 1.11. Okay, thank you.